My name is Jahn, and as usual, together with OW2, this time with Pierre-Yves Gibello, we are your hosts for this episode of the Open Research webinars. Pierre-Yves just recently became the new CEO of OW2, so maybe Pierre-Yves, you want to say a few words about yourself and that change?
So I'm Pierre-Yves Gibello. I'm the new CEO of OW2. Maybe those who already knew OW2 have met Cédric Thomas, who was I should say, the historical CEO of OW2. He led OW2 for 15 years, so it's a big change in the story of in the OW2 story. I just started my function in April, so I'm really a brand new CEO, but with a quite long history at OW2 because I was there at the early beginning, almost 20 years ago, with one of the first open source projects hosted by the association. Then I spent 10 years at the board of OW2 as an elected board member because I had my own company, which was a member of OW2. So I knew the association for a very long time, and I've been working a few years as a research engineer recently for OW2 projects before joining as CEO. So here I am to help Marco introduce the Eclipse OW2 webinar.
Yeah, thanks a lot, Pierre-Yves, and I'm looking forward to host these webinars in the future together with you. Yeah, we're already in the 6th episode of the Open Research webinars, which means we already had quite a couple of nice and interesting presentations of open source projects that are coming from European research projects and European research in general, right? So what we want to do in these webinars is bringing together researchers, but also developers and industry people to learn from interesting and sustainable and long-term research results that lead to successful open source projects. So that's the idea of these webinars. And that's what we always want to do as the open source foundations, OW2 and Eclipse Foundation, to support research becoming successful, becoming great, building large ecosystems, developer communities, and so on. So you can find the recordings of all the previous webinars on our website, opensourceinnovation.eu. You find the presentations and the talks. We had a wide range of topics already, from cloud to industry 4.0 with Eclipse basics, Set4j, Eclipse Steady for mitigating privacy issues, and a lot of more interesting topics. So feel free to have a look at the website and look at the previous recordings if you're interested in any of these topics. What do we have on the agenda today? As usual, we have two interesting talks. We have Alessandra Bagnato from Softeam, who will talk about Morphemic, the cloud computing optimization platform. And the second talk will be by Jos Hegge from TNO about validating your system architecture early by simulating with Eclipse POOSL. Yeah, Olivier already said we are recording this session, so please mute your mic and turn off your video if you wish to remain anonymous. After each talk, we have 5 minutes of Q&A. If you have a question to the presenters, please raise your hand in the virtual hand in the Zoom control. You will find that from the participants list, or just put your question into the chat and we'll read it to the presenter afterwards. All right, before we start, a couple of small announcements to make from our side. We are very happy and proud that EclipseCon this year will be back live in Ludwigsburg again. So we will be able to meet again face-to-face, meet real people, and come together and network together, meet the community. So we're really happy we will be back in Ludwigsburg this year. And the call for proposals just recently opened. So go ahead, submit a talk. As usual, we have lots of interesting tracks from cloud native technologies over automotive, mobility, IoT and edge, classic Java, web desktop tools, and so on. And if you are doing some awesome stuff that does not fit any of these categories, we still have the track of other cool stuff. So if you're doing robots, machine learning, rockets, blockchains, whatever, as long as it's open source, go ahead and submit your proposal. And for the first time this year, we are co-locating a scientific sub-conference with EclipseCon, which is called SAM on Cloud. That will be co-organized with CERT and ATB. And it's about security, privacy, AI, architecture, and modeling for the next generation of edge cloud computing continuum. So this will be more scientific oriented part of the EclipseCon. The website on that will be launched very soon, so stay tuned for that. We will announce it in the usual channels. And with that, I would hand over to Pierre-Yves again to talk about OW2Con.
Okay, so concerning OW2Con, it will take place in Paris. First, it will take place online, in fact. Usually it's a physical event, but we kept OW2Con online for at least for the event itself on June 8 and 9 on our site. So you can see everything, all the program on ow2con.org. The main topic is about reliable and predictable open source software. And so you can see there some experts from the community and from beyond all around the world talking about open source software in modern corporate information systems. So that's the main point of the event. And then OW2 we also organize a physical event which is co-located with a cloud data center event in Paris Exposition Park at Porte de Versailles. So this will be on the 29th and 30th of June with a social event, which is the 15th anniversary of OW2 that we will celebrate also there. It's on invitations, but of course, all the community is invited, all the sponsors are invited, and also people that are interested by open source software and that are part of our contacts and community and interested in the event can just ask for an invitation. So you can check everything. You can check everything on ow2con.org to get information and contact us if you want. Very quickly, Alessandra Bagnato is a research scientist and she's the head of Model.io research unit at Softeam Software, which is part of DocaPost Group. She holds a PhD degree in computer science from Télécom Sud Paris in France, and also a master in computer science from the University of Genoa in Italy. At Softeam, she leads the Softeam Model.io team research around innovative model-driven engineering in the area of cyber physical systems, cloud, and big data. So that's what it is about concerning the European Edge 2020 Morphemic project that she will present now.
Thank you very much for the introduction and for the invitation to this very, very nice webinar, which I found really, really interesting and helpful for the world community. So today I'm very happy to be here to present to you the Morphemic project, cloud computing optimization platform. We will describe during this talk the Morphemic project and its unique way to adapt and optimize cloud computing, starting from the cloud application modeling and execution language, CAML. And we will go through it, and you will have some example of that, and you user can specify different aspects and domain related to multi-cross cloud application, such as deployment, requirement, metrics, scalability, security, organization, and execution. So the Morphemic project is an extension of the Melodic project that is a multi-cloud platform that has been developed during an Horizon 2020 project as Morphemic, that is also an Horizon 2020 project. Morphemic builds on top of this open source platform that is hosted on OW2 and adds to that the ability to run and deploy components depending on their requirements and workload. So in virtual machine, containers, so big data job, and also it foresees the concept of proactive adaptation. So we are aimed to forecast the future resource needs and deployment configuration. So the idea and the Morphemic vision is to simplify this cloud application modeling and to continuously optimize and morph this cloud application. Also, we are aiming to solve the problem of data intensive applications. So cloud applications that are already data intensive and that they can deploy in a better way their components. So the Morphemic application, very briefly, it's depicted in this slide. We have some melodic and components that have been reused, as I mentioned, and some specific components that have been developed during the project itself. We are going to have a part for profiling the different data input application modeling, some reasoning, and some execution for real application deployment, and also some monitoring where we are going to measure through metrics what is happening to be able to produce forecasting of the future resources. In here, you can see a picture that you may have already seen from architectural blueprint from automatic computing from IBM. So the approach is to model, to follow up with analyze and plan, to execute and to follow up the monitoring. So the part where we are focusing today is the modeling. We want to use a cloud domain specific model where we describe the application, we describe the deployment context and the deployment goals. So if we have requirements and if we have any constraint. Then we have the analyze and plan where we have some specific morphemic intelligence that helps the user to stabilize utility, and we have the monitoring, and then we have the execution, of course. What is doing this cloud application modeling execution language that is the starting point of this morphemic platform is to allow the user to give their requirement to deployment, metric, scalability, security, and organization. This language is already used in many projects, of course, Morphemic, but also Passage, Cloud Socket, and Melodic. In here, you can see what Modelio Camel Designer look like. We have in the tool that is open source and in research and development GitHub, you can see a model explorer where you can have all the different diagram and model that can be included in the cloud modeling. So you see in here some example of requirement model. You can have some organization diagram and some requirement modeling and some deployment model. And in here, you see the nice Modelio palette that allows you to model the specific elements that are specific to each one of these different diagrams. And a very important point, you can import and export this model. And that is the way that we are using to give this nice model to the whole Modelio platform. In here, you can see an example of a security model diagram. The model explorer shows the hierarchy of the persistence model, and you can create, delete, copy and paste all these model elements. And then within the Modelio Camel Designer, you are there to use a set of tools where you can modify this model and you can customize the appearance of the different elements. And of course, you can link the elements as it should be done. In here, you see the security controls and security domains for this application and interface security. And In this slide, you see how this camel model is to be uploaded in the whole Morphemic platform. So the Morphemic platform starts from this model to provide all the cloud application, cross-cloud application information and the forecasting that I've mentioned before. If you are interested in seeing a demo of this Morphemic platform, you are very welcome to join OW2 conference that has already been introduced and mentioned on 8 and 9 of June, and to join the Morphemic chat room, where we will be very happy to organize specific demo for you and to invite you to have also some test on what we have done so far with the wall platform. So in here you see the starting point. We are uploading a camel file in XML format that has been downloaded, that has been exported from the Modelio Camel Designer. So what are the benefits of this work of Morphemic? We want to help data-intensive cloud application performance and usability. We want to maximize their performances and usability, deploying them in the best environment that has been identified with clear decision parameters that, of course, have been modeled on our Modelio Camel Designer. And we can also improve the application with predictive analysis of the application future states. And that is the really innovative part of Morphemic. I will not show that today, but as I said, you are very welcome to join us at OW2Conf and also to ask for a demo from us. We will use our chat booth as a virtual booth so we can organize demo for you. Data intensive application and then offered a selection of cloud provider, so there may be relevant cost saving and we can avoid vendor lock, because of course we will have the better solution, the best solution for each one of the components, for each one of the needs. And of course we all know how much cloud costs are impacting everyone these days, everyone using of course cloud application. And in here I added a few references that you can have a look to. So of course the Morphemic project website, the Camel Designer module for Modelio that is, as I said, available on GitHub, the Modelio open source community, and all the information on this Camel DSL. The Camel DSL is also improved through Morphemic, and of course we are making it evolve. And of course the Morphemic platform on OW2 GitLab that is available in the following link. So I thank you very much for having listened to me, and I hope to meet you also at the OW2Conf, also for a nice demo. And you can follow up our Morphemic project on Twitter. I've put in here the link, and if you want to write to me, of course, in here are my contact details. So thank you very much in all languages, and thank you, of course, again for the invitation to these open webinars. I don't know if you have any question, please.
Concerning the Camel DSL, did you think of, because you said it was used in several projects,
Yes.
just Morphemic, did you think of making it a standard, for example, at W3C or some other body?
Yes, I mean that is a nice potential ideas. We are now working for this DSL evolution, and the DSL will not end with Morphemic, because of course it's going to be used in many other cloud projects and initiative. So of course we are studying the situation of standards. We have not yet have a standardization sponsor, but let's see that we see that a bit of a de facto standard, but it's in our wishing list to be able to make it a standard with the time.
So our next speaker is Jos Hegge, and Jos is a research project manager at TNO. He has a master's degree in electronics from Delft University of Technology in 1986 and worked in multiple organizations as researcher and research project manager. His focus in the past has been on system and software problems and formal software design. And currently at TNO, he's responsible for several research projects on system development methodologies. And in that context, he also is involved in the transfer of Eclipse POOSL to open source. So, Jos, the floor is yours.
Thank you for this nice introduction. I hope my screen is now fully visible.
Yes.
All right. So the talk is about POOSL, a simulation environment for early system validation. And the name POOSL stands for Parallel Object Oriented Specification Language. It is typically a very lightweight environment, so intended to create a model quickly, and that will allow you to study several aspects at a very early stage of development. It was originated at the Eindhoven University of Technology and then further extended by TNO. And also we applied it on several applications in high-tech companies here in the Netherlands. At the moment, it's being industrialized by Gibello as an Eclipse open source project. So the outline of this presentation will be on the purpose of POOSL. I already highlighted a little bit of that, the POOSL language and the tool features, and then I'll show a more extensive example from the European project Transact. So the purpose of POOSL is early system validation, because we know that at a very early stage of a project, we have to look at requirements that are often very imprecise or incomplete. And we need to take many architectural decisions, for example, on the decomposition or all kind of interchanges within our environment. And if we miss out on some of the important aspects there, or we introduce a problem, and we find that out only very late in the project, that often has a big consequence in terms of time or effort to repair that. So the goal of the tool POOSL is to allow you to make all kinds of simulations on several aspects that are very important, and to get a bit more certain feeling about those issues. So in other words, to reduce risks. Well, examples of early system validation, for example, functional requirements, not just the feature that the user requires, but also the interaction between features. The decomposition, how do several components that you define, how do they work together as a system? And of course, looking at all kinds of performance indicators like time, the resources used, the memory, the throughput, and the responses. Well, typical approaches in industry are just plain drawing tools or some elementary calculations, or at the other end of the spectrum, physical or virtual prototypes. Well, POOSL is intended to be somewhere in between, so it is lightweight. It allows you to model a particular aspect at the level of detail you like, but it can be very abstract, and then study the impact in a realistic simulation. All in all, to reduce risk later on. Now, the POOSL language, the decomposition, the process behavior, and the data structures. First of all, POOSL is based on communicating processes, and you do that in a tree-like fashion to make it scalable. So you have lots of communicating processes, and you can look at an individual process to look at some details, but you can also look at the system as a whole. The process itself you describe in a kind of textual manner. So this is the model description. You can describe the messages that are sent out, but also the messages that are received. all based on the principle of synchronous messages. You can model the parallelism between those processes in that way, but also internally. You can deal with non-deterministic choices, for example, based on events or other aspects that come from the outside world. You can model time delays, in that sense, build your model based on a realistic view of how the time is distributed in your application. And you have some basic concepts like aborts and interrupts. On the right, you see an example of a process description, but I'm not going to discuss that here. Of course, when you talk about messages and describing what is happening inside the process, you're dealing with data elements. And we support all the object-oriented features that are well known from object-oriented programming languages. And next to that, we also support all kinds of APIs and libraries. Well, you see a list of those here at the bottom. I want to highlight just one, the socket interface, which is very interesting if you want to also integrate with, for example, a 3D modeling environment to build very powerful visualizations or UIs. And that in the combination will support you in making a very nice, rather realistic simulation, even though the model itself is still at an abstract level. On the right, you see an example of such a data class. On the tool itself, it is based on Eclipse, so you can do the textual editing of your model, navigate through your models, have all the features of Eclipse supporting you in that process. Next to that, you can also do graphical editing. In fact, the graphics and the textual model go hand in hand. And of course, also the graphics allow you to navigate through your models, etc. And there are some basic validations on the model in the tool. Basic type checking, warnings for some problems found, etc. In the interactive mode, you can do the simulation. You have all the well-known features like breakpoints, single stepping, looking at the threads, inspecting stack frames, looking at the values of variables, generating sequence diagrams, etc. And you can do this execution both from this IDE in a more interactive fashion, but also use it from the command line in a batch-like fashion. And here you see an example screen. So on the left, you see again the model. In the middle, you see a textual or a graphical representation of this model. In this case, just two processes interacting with each other. And on the right-hand side, you see a message sequence chart that was generated during one of these simulation sessions. And at the top, you can look at various elements internally in the models. For example, on the right-hand side, you see the variables and their values. Then a POOSL example from the European project Transact. So in this example, we start from an operation room, in this case an operation room at Philips, where we want to model the image-guided support for the processing of very complex pictures. Now, of course, if you want to offload these pictures to a cloud server, you must ensure that somehow that the time that it takes to process such a picture is not too long, because otherwise it becomes impractical during an operation. So it's not hard real time, but still there is an element of a hard timing requirement on it. Now, if this just is for one operation room, obviously this is rather simple to calculate, but in practice we deal with many such requests during an operation. And what is even more important, we deal with many such hospitals and also many operations at the same time, and many operation rooms that run in parallel. And the big question then, of course, is how many cloud resources would you need in order to achieve the timing requirements that are stipulated in the SLA. And for that, we have created a POOSL model, because in fact we find that POOSL is the ideal environment to model the rather stochastic, time-varying dynamic behavior. Because you can imagine that an operation, well, all of these operations more or less start around the whole hour, and then they follow a kind of standard pattern where first the patient is put on the table, some basic dealings with the patient are done, and step by step we run up until the moment that this advanced image processing is required. And then several of these requests will probably follow. And the nasty problem is that all of these operations will follow a kind of the same pattern. So these requests typically come in bursts and then need to be dealt with. At the cloud side of the situation, we have to model the intake of the data in order to do the processing of the images, also the buffering of the data, the interaction through the web interface for the surgeon, etc. So also at the cloud end, we have created a model that reflects the real-time operation of how this processing of images takes place. And now if we bring that together, we can look at the operations individually. And on the left-hand side, you see, for example, some steps that are taken during the operation and the events that result from that. And at the bottom of the picture, you see the load on the execution queue between the cloud server and the several operation rooms. And as I explained before, this load typically comes in kind of bursts with a higher load at some point in time and practically zero load at other points in time. But of course, we are interested at the peaks because those determine how many resources we would need at our cloud application. And here you're seeing an example where we have tried it out with just one cloud resource. And then you see in the histogram that, well, actually only a small part of it achieves the processed image within the timing requirements that are defined by the SLA. And a large section of the requests are coming in simply very late, and a few even at a very, very late statement, as you can see in the image. Now, if we increase the number of cloud instances, the cloud resources, you can see that, for example, in this case, we have modeled having 3 cloud resources available, and then you see that the majority of the requests is coming in time. Well, by doing this in this model, this allows you to play with these parameters and get a feeling for, in this case, how many cloud resources are needed. But of course, you can make the model as detailed as you need, and you could, in theory, also look at all other kind of properties, and then also come up with the properties that are required by the SLA in an optimal way. So in fact, this is a very nice example that it not only helps in what I mentioned at the start, the early system simulation for early analysis of all kinds of problems. This model is even could even be used later on during the operation of these hospitals. If, for example, you would add an hospital and then you would like to investigate in what sense that impacts the cloud application that you have and whether or not you need to modify the SLA. Well, I can only invite you all to give it a try. Here you see several links. First of all, the general POOSL website. You can also find the source code in GitHub. And if you want to learn more about this Transact project, here is the reference to Transact. So thank you all for your attention. And if you have questions, please fire ahead.
Maybe I give it a try. Jos, you said in the beginning that POOSL was or is being industrialized by Obeo. Could you say a bit more what that means? Are they developing, I don't know, custom-made tools and have a business model on that, if you know something in that direction?
Obeo indeed is taking the source code that we have released, and they're, well, doing some cleanup in the sense that they have certain standards for the tools that they support. So they want to modify the code a little bit in that respect. Also, they are real experts on Eclipse, for which, well, the authors in the tool obviously are not. So they have some ideas how to improve on the integration in Eclipse, and they're also providing that support. In the end, Obeo indeed wants to make this into a sustainable business for them. And they have a model where the tool in itself will remain open source, but you can establish a support contract with Obeo. You can also obtain trainings from them in the tool. They can even provide some consultancy if you want to apply it in a real industrial project. Of course, we as TNO will remain a very active user of POOSL. So we will also use, in effect, the version that they will now release to open source. And we will also support them in their activity to turn this into a sustainable business.
Interesting. Oh, that's pretty interesting, and that sounds like a very, very nice example of how, you know, open source can lead to such collaborations between research and then lead to industry and making sustainable business. So that sounds really interesting and like a great success from my point of view.